All right, let's just jump right in. Welcome to today's explainer. We are cackling what is arguably the biggest paradigm shift in software engineering right now, AI agent observability. Look, if you're building or trying to maintain AI agents in 2026, you already know the painful truth. Traditional application performance monitoring, it just doesn't cut it anymore. We're dealing with a totally new beast. We absolutely have to move past those standard health checks if we actually want to understand what our autonomous systems are doing out there in production. So today, we're going to break down the exact tracing and monitoring stack you need to actually keep your agents under control. Here's our roadmap for the explainer. First, we'll look at why agents break differently. Then we're going to check out the OpenTelemetry GenAI standard, dive into context propagation and MCP, talk about how to actually choose your observability stack, and finally, we'll wrap up with cost tracking and evals.
So, Section 1, why agents break differently.
If you've ever spent hours pulling your hair out trying to figure out why a production agent just went totally off the rails, you need to hear this quote from Aryan Kargwal at Polytechnique Montreal. He hit the nail on the head. He said, agentic systems fail in ways that look like success. Think about that. You might get an output that's beautifully formatted, super eloquent, and completely hallucinated. Or maybe the agent actually finished the task, but it made 3 totally unnecessary, wildly expensive tool calls to get there. Traditional monitoring is literally blind to this kind of failure.
It's a massive paradigm shift. Think about traditional deterministic services. You get a 200 OK or a 500 internal server error, right? It's binary. You keep an eye on latency, watch your error rates, maybe read the logs when something crashes. Easy. But AI agents? They're non-deterministic. They can fail with the smooth, unwavering confidence of a professional con artist. You can fire off the exact same prompt twice and get a completely different sequence of tool calls just based on a slight temperature tweak or a different retrieval result. So, a basic health check that just says the service is up is practically useless now. Step-level tracing, where you record every single reasoning step, every tool execution, every model response, that is now your bare minimum. It's the new baseline.
Which brings us to Section 2, the OpenTelemetry GenAI standard.
Now, this standard is essentially the hero of our story today. OpenTelemetry GenAI version 1.41 is an absolute game changer because it completely decouples your instrumentation from any specific vendor. You want to switch platforms? Go for it. No need to rewrite all your telemetry code. But there's a trap here, and honestly, a lot of people miss it. The standard is currently in development status. That means attribute names, like genai.usage.input tokens, can still change out from under you without a major version bump. To protect yourself, it is absolutely crucial to use the dual emission opt-in. It's basically a safety net that emits both the legacy and the current attribute names. That way, a sudden upstream change doesn't just silently break all your dashboards.
Let's take a peek under the hood at how this spec actually works. You've got these different span operations, things like create agent, invoke agent, and execute tool. But you really want to pay attention to the span kind. For example, an invoke agent span is going to be tagged as a client kind if you're reaching out to a remote API, like OpenAI. But it's an internal kind if it's running locally inside a framework like LangChain. The real magic, though, that happens with the invoke workflow span. If you're running a multi-agent system, a single internal invoke workflow span acts as a parent, and it wraps multiple invoke agent children. This hierarchy is exactly how you make complex, multi-agent handoffs actually legible inside a single trace. It's like a giant puzzle, and this puts all the pieces together.
Moving right along to Section 3, context propagation and MCP. Okay, so we have the standard, but how do we actually keep these traces connected when our agents are spread out across a bunch of different distributed services and networks? The answer is context propagation. Think of it like a baton pass in a relay race. When service A calls service B, it has to pass the baton, which in this case is the trace context. Step 1, service A injects that context, like the trace ID and span ID, right into the network headers. The industry standard for this is the W3C trace context headers, specifically using the trace parent key. Step 2 is just the network transport. And then, step 3, service B extracts that context and uses it to create a child span. If you drop the baton, if you skip this pass, service B just blindly starts a brand new trace, and you end up with a mess of disconnected fragments instead of one unified view of your agent's journey. And this next part completely changes how we handle the tool layer, which, let's be honest, used to be a total black box. With OpenTelemetry version 1.39, we got Model Context Protocol, or MCP, tracing.
Now, when your agent uses an external tool, the MCP instrumentation doesn't just lazily create a new, noisy duplicate span. Instead, it makes an incredibly clever design choice. It actually enriches the existing execute tool span with the protocol mechanics, things like the method name and the session ID. It totally opens up the black box of the tool layer, but it keeps your traces incredibly clean and readable. No extra clutter.
All right, let's get practical. Section 4, choosing your observability stack. If you are an architect making buying and deployment decisions right now in 2026, I want you to consider this pretty wild statistic from Gartner. Only about 15% of GenAI deployments have actually instrumented observability. 15! That means 85% of deployments out there are essentially flying blind, just crossing their fingers and hoping for the best. By instrumenting step-level tracing right now, you are literally buying yourself an unfair competitive advantage. Because when something breaks, and it will, you're going to know exactly why in minutes, while your competitors are stuck blindly guessing and rerunning prompts.
Now, before you even look at a single feature list, you have to pick your stack based on the deployment model. There are 3 main options here, and they each come with a very specific trade-off. First up is self-hosted. This is going to be your best bet if you have strict data residency and sovereignty requirements, making sure your data never leaves your perimeter. Second is the managed SDK. This is all about speed to value. You drop in an SDK and the vendor handles the entire backend. Easy. Finally, there's the proxy gateway, which routes your traffic through a gateway to give you zero code change cost tracking. But be very careful here. A proxy gateway introduces a major single point of failure. If that gateway goes down, your entire fleet of agents instantly loses connectivity to all models simultaneously.
So, to help you out, here is a quick 2026 cheat sheet. For self-hosting, you've got platforms like Langfuse and RI's Phoenix. For managed SDKs, look at Langsmith and Braintrust. Helicone is a big player for the proxy model, and of course, Datadog if you want to extend your existing APM. But whatever you do, pay very close attention to that final column, the 2025-2026 signal. The AI observability market is consolidating ridiculously fast right now. You have to look for durability signals to ensure you're choosing a stack that you won't be forced to rip and replace next year. Things like ClickHouse acquiring Langfuse or Braintrust raising an $80 million Series B. Those are massive signals that these platforms actually have the capital and the backing to stick around for the long haul.
And finally, Section 5, cost tracking and evals.
Look, observability isn't just about knowing what the agent did. It's also about controlling the financial blast radius. And cost observability for agents has a really sneaky subtlety to it. Pricing models diverge wildly at scale. Why? Because they measure completely different units. Braintrust meters pretty generously by the span. Datadog meters specifically by the LLM span, which means your tool and retrieval spans are technically free. Helicone meters by the request, and Langsmith meters by the trace. The big takeaway here is that a highly agentic system, one that makes dozens of tool calls for every single LLM call, is going to be dramatically cheaper on a span class-aware model, like Datadog's, compared to a flat per-span model. You absolutely have to model out your specific traffic pattern before you just assume one platform is cheaper than another.
We also can't talk about monitoring without talking about eval gates. Because tracing tells you what happened, right? But eval gates tell you if it was actually any good. The mature pattern for 2026 is pairing your runtime tracing with automated scorers. These eval gates actually grade your agent's outputs in real time. They are absolutely essential. They flag quality drops, they block regressions before they ever reach your end user, and, this is critical, they defend against prompt injections. Think about it. A trace might look perfectly clean and structurally sound, even if the agent is secretly executing malicious injected instructions in the background. Evals catch that. I want to leave you with one final kind of provocative question to think about. If you cannot explain why an agent did something, do you really control it? As we've seen today, step-level observability is just no longer an optional add-on. It is a fundamental, foundational requirement before you let any agent make autonomous decisions in production. So adopt the OpenTelemetry standard, choose your deployment model wisely, and instrument those traces so that when the inevitable happens, you actually have the answers. Thank you so much for hanging out with me for this explainer. Keep learning, keep building, and stay observable.